JavaScript is the language of the web and as such is used to create anything from simple static pages to highly complex web applications. While it had no other practical applications in the beginning, the decades after its creation, as well as newer versions, have introduced a variety of methods to write JavaScript for other purposes as well, such as, for example, Express.js or Nest.js for writing server-side JavaScript code, as well as Electron or NW.js for writing general native desktop applications, and React Native, let's say, for writing native mobile applications. Knowledge of JavaScript can be incredibly useful in this day and age, so without further ado, let's get right into it. Now, I have an index.js file right here, and I'll start with writing my code in here. So the first thing we need to do is figure out how to use variables. We can simply think about variables as storage containers, and since JavaScript is what is known as a dynamic language, there are no special rules for different data types when declaring variables. To create a variable, simply name it and put a special keyword before it. I'll name mine variable. Now, when it comes to this keyword, it can either be let, which creates a variable that can be mutated or changed and reassigned in the future, or const, which is basically a constant. This is a read-only type of variable, and if it's a primitive value, and we will not be able to reassign it. There is also a third keyword, the var keyword, which is used to declare variables, and it was used a long time ago before modern JavaScript. There are a couple of weird quirks with this keyword, so I would recommend avoiding it. And if we need a mutated variable, simply stick with let. Otherwise, the constant would be perfectly fine. It usually behaves the same way as let, but there are some instances where it can break the code, since it's not as foolproof as let is. Now, the next thing after we use the keyword and the variable name, and I'll change this to let here, is the assignment operator or the equal sign, followed by the value we intended to store in the variable. Now, very broadly speaking, we can assign two different types of values to variables, those being primitive and non-primitive, and I'll spend some time talking about them. Now, primitive data types are a string, which is simply a string of characters wrapped inside of quotes, like these, for example, double quotes. It can also be anything, doesn't have to be text, for example, a number as well, let's say 500. Now, aside from strings, we also have, let's change this here, we also have numbers as a data type, which is just a number without the quotes, simply symbolizing a numerical value. Now, JavaScript doesn't make any distinctions about whether it's a whole number or an integer, or a decimal point number or a float. So this is perfectly fine. We could also say num2 is 100.65, which will be treated the same way as this number right here, regardless of this being a whole number and this having a decimal point. Now, the next type of data, which is a primitive, would be a boolean, and it only has one of two different values. So it's either true or false. true, false, and these would be considered, well, quote-unquote Boolean, but they're basically used for any binary operation that resolves to either a true or a false, such as or ternary operations, such as maybe in conditional statements. The other two remaining values that are primitive or data types would be null and undefined. And null represents the absence of any value within the variable, while y simply states that it's undefined and therefore has no preset value. When it comes to the complex and non-primitive data types in JavaScript, there is officially only one, which is the object type, and it looks like this. We simply open up curly braces and put in a key value pair of anything. For example, say name, Peter, age 55. In this example, we've created an object with 4 different properties, those being name, age, is married, and has children, as well as 4 different data types like string, number, boolean, and null. As a single variable, this will be considered a non-primitive data type. Something else that can also be considered non-primitive data type is an array, which is simply a container of containers of sorts. If a variable would be considered a container, then anything put here between these 2 square brackets would be considered one of its values. For example, let's just put a couple of numbers separated by commas. And in this case, each of these numbers is its own separate value because they're separated by a comma, and we can access each of them individually, which I will talk about more in the next video. Now, once a value is assigned, we can do operations with the variable it's represented by. These operations are mostly basic arithmetic from school math class, as well as a couple of new things or different notations. And there are 3 different kinds of operations regarding how many members they require. Those would be unary, binary, and ternary operators. Unary operators would be something like changing the positivity of the number. For example, if I said negative num here, this should resolve to negative 500, since number is a positive 500 value. And this would also work with the positive sign or plus, but honestly, the positive sign really doesn't change much and it can just be omitted, so that's what happens, usually. And now when we see the value of number, it's negative 500 here. Now, binary operators are, for example, anything doing with basic math. Now, y is 1, z is 2. This here would be simply considered a binary operation. Let's just check its value. Oops. y has already been used. Alright. Two more things of note here are the exponentiation and the remainder operators. Now, exponentiation, or raising something to the power of something else, is written as 2 stars, these ones. And it looks kind of something like this. And as we can see, the value is 8 by simply raising 2 to the power of 3. So this is the base and this is the exponent right here. Now another one would be the modulo operator, and I'll use this x1 as an example here. Simply by using the percent sign here and a number as a divisor would yield us the remainder in this case. So 3 can only be found twice in 8, and that's 6, and the remainder of that is 2, so that's the value assigned to the x2 variable. Another thing we can do with the numbers are increments and decrements, which will either take a number and increase or decrease its value by 1 respectively. So if I do x2 plus plus, we will get the value of 3. And if I do x2 minus minus, and then see it again, we will decrement the value by 1 and return it to its original value. As an added bonus, we can also modify the numbers in place and restore them into the same variable. Now, we could write this, for example, like x2 is equals x2 plus 5, for example. Which is something that's done quite often in most programming languages, and JavaScript has a nifty little feature that helps it achieve this much more quickly. And that's simply by not repeating the variable name and just doing this. Plus equals 5. Now if I see the value of x2, it simply gives us 7. So this expression here is basically equal to this. This also works for every other well, operation we know of. For example, multiplication. Subtraction, and division. So that's about that. Now, when it comes to the plus operator or addition, it's not used with numbers and numbers alone. It can also be used to concatenate strings. For example, let's say we have a string of hello and world here, and let's assign them to a separate variable called y3. And when we see y3, we simply get the text hello world. Simply literally smushed together from these variables. Now, aside from that, other operations with numbers and strings are also possible as long as the string represents a numerical value. That's because JavaScript simply changes and converts it to a number before doing anything. So if I write something like 100 as a number divided by 10 as a string, and I see the y4 value. It simply gives us a number 10. Not a string, but a number, which is fairly important. And this will generally work for other arithmetic operations other than addition, since addition is basically concatenation. Now, if the operation is not successful or it cannot be executed, something else happens. So instead of giving us a number, let's just try to divide 50 by the string hello. And when we see the result, it gives us this NaN, which basically stands for not a number. And this is basically a useless value and nothing can be done with it. And it's usually a good idea to check whether the operation resolves to not a number, so the application doesn't burn up and destroy itself. Now, the last thing I'm going to talk about in this video is the ability to print or log to the console. It's done by using the console.log function, and it does one of the following things. If JavaScript is being run on the server side or the terminal, this thing here, it'll simply print stuff to the console there, but if it's being run through the browser, it'll print the return value in the development tools. Console.log will take as many parameters as necessary by the developer, but it's usually done with 1 or 2. So let's try something. And that's basically how the console.log is used.